Good morning, everybody. We talked about hemodynamics, we talked about bioacoustics early. Today we will start to talk about electrostatics. We must discuss an important topic in physics. Electricity, electrostatics is the important topic of physics. And before talking about electricity, let's remember the historical information. Firstly, we should say what is about electrostatics, definition of electrostatics. This is a branch of physics that studies electric charges at rest. I think you know it. So, and we should remember, we should know what is about word electric, electrostatic, electricity. This word electric comes from the Greek word electron. From Greek language it is the amber. This is the amber. You can see the right picture. But why amber, you ask? And what does amber have to do with it? We're not in a jewelry store. So, but amber is here for a reason. Back in the 5th-6th century, and Thales Miletus first observed the electrical interaction of bodies when amber was rubbed with wool and objects were attracted to it. So, therefore, this is how the name was obtained. And according to this, many years ago, and in the 18th century, Benjamin Franklin proposed two types of charges. This is plus and minus. And as it became known that there are two types of interaction, attraction and repulsion. After that, this was the main idea of this. There are two types of interaction, attraction and repulsion. And please remember that there are two types of charges, plus and minus. So now let's move on to concept of what an electric charge is. What is about electric charge? Let's see the definition. An electric charge is a physical quantity, how you can see in the upper part of slide, is a physical quantity that characterizes the property of bodies or particles, different particles, to enter into electromagnetic interaction and determines the values of the forces that arise during such interactions. You and I know that there is a positive and negative charges, how we said earlier. And if we look at the atom in the figure on the left, then we see and know that there are positive protons in nucleus and neutrons, neutral neutrons are in nucleus of the atom. And there are negative electrons which moved around the nucleus. Yes, I think you know this information from chemical department, from chemical lessons. You must know it. So, and if the number of electrons in atom is less than that of protons, then this is a positive ion will be. And opposite, or the contrary, there are more electrons than protons in the atom, so this will be a negative, this will be the negative ion. I think you know. So we must remember with you about two types of interaction. We said about it earlier. This is attraction and repulsion. So two positive charges or two negative charges, how can you see on the slide? They are attract. So repel, yeah? So like charges repel. And if we have opposite charges, plus and minus, we can see the attraction of them, yeah? Opposite charges attract, and like charges repel. I think you know this information. Just like in life, yeah? We can compare it with our life, because the physics is the base of our life, and our life is based on physics. So we can compare it. So just like in our life, if you remember, for example, your parents or your grandma or grandpas, or maybe you have a wife or you have a husband maybe, so, and for example your parents, then most often, for example, they are completely different people with us, yeah? For example, mother is active woman, for example, and father is lazy man, for example, and maybe opposite, mother is lazy woman and father is active man, and but at the same time together, yeah? Likewise, we are always interested in people who are very different from us in character, yeah? We can't interest in people who are the same, who has the same character with us, for example, because it's not interesting for us. It's interesting to us to talk with different people. For example, if we are lazy people, we should interest in active people, and maybe opposite, for example. And we do know the charge by letter Q and the system of unit measure. So don't forget, yeah? System international units of Q is coulomb. Yeah, and we put the letter Q is the charge. And I think you know the main information about charges in atom. For example, the charge of electron is a negative value, and what number is? Minus 1 power 6 multiplied on the 10 in the power, minus 1.6 multiplied on the 10 in the power minus 19 coulombs. And for example, if we have the charge of proton, it will be positive number, the same number but positive. So after that, we must also tell you what substances are in terms of electrical interaction in our life. So there are 3 types of substances in total. I think you know this. There are conductors, dielectrics, and semiconductors. And let's take a look at each of them. Firstly, we start to talk about conductors. What is about conductors? Yeah, conductors are substances, yeah, that can conduct electrical charges. I think you know these examples. For example, maybe iron, copper, gold, and other metals. Yeah, this is the metals, especially metals. In the chemistry, I think you know from chemistry, you know this information. And why they can conduct the electrical charge? Because it's possible, since they have free charges. They have free charges, and so they can conduct the electrical charge. Because for conduction, we must take the electrons, atom must take electrons in the vacant, yeah, and after that they give up to other atom. And so if they have free charges, they can conduct the electricity. So further, dielectrics and opposite, yeah, dielectrics are substances that don't conduct an electrical charges. Why they can't conduct electrical charges? Because they have no free charges. For example, maybe glass, ebonite, and maybe wood, yeah, plastic, and other materials. And they are not capable of conducting a charge under normal conditions, yeah, and usually. But they can become conductors at very high charge values. Can become conductors at very high charges. Don't forget, please, this information. And the latter are semiconductors. What is about semiconductors? Why we have semiconductors? Maybe conductors, maybe dielectrics. What is this? Yeah, we must say. So semiconductors are substances too that behave like conductors under certain conditions. For example, rise temperature, illumination with light, or ultraviolet, yeah, action, and other special conditions. Yeah, if we have these special conditions and act by it on semiconductors, and after that semiconductors can conduct electricity. But if we have no these special conditions, so semiconductors can't conduct electricity. And examples. These are, for example, substances such as silicon, germanium, carbon, and other materials. So let's continue. Let's continue to talk about electricity, and we said earlier that we have types of interaction of charges, yeah? Again and again I will repeat these types of interaction. This is attraction and repulsion. And this means how we saw earlier that the charges are capable of acting on each other with some force. In order for us to calculate it, there is Coulomb's law. From many careful experiments directly measuring the forces between static charges and from successive observations of many other things, such as the electrical structure of atoms, the conductivity of metals, the movement of charge particles, and much more, we conclude that for any two stationary charges, the experimentally confirmed electrostatic force acting on charge 1 to charge 2 is. For example, in yellow picture, you can see this example. There are two charges, Q1 and Q2, and there are different charges. Q2 is minus, Q1 is plus. And so we have in this, we have the attraction of these charges, because we know that different charges are attracted. So, and what is about? We have red color of negative charge and blue color of positive charge. So, this positive charge attract the negative charge with the force F 2-1, from 2 to 1, yeah? It's not 21. This is the direction of force, from 2 to 1. Where? Yeah? So, and opposite, the negative charge can attract the positive charge with red force 1, 2, from 1 to 2. So, and between these charges, there is a distance r. So maybe L distance, yeah? So, and we must know this force, yeah? For example, we have two different charges, plus and minus, but these charges may have the same number of charge, but maybe only other direction and other plus and minus, yeah? So other charge, yeah, plus and minus. So how can we calculate and how can we know this force according Coulomb's law? Let's see in a green part. Let's see in a green formula, in a green part. How can we know this force? We should take the K, multiply on Q1 and Q2 and divide by R in square. So don't forget that we should take the absolute values here, the absolute values of these charges. And what is about R? We said that this is a distance between charges. What is about F? This is a force of interaction. And what is about K? This is a special coefficient with the same numbers everywhere, every time. 9 multiply on 10 and the power 9. Newton multiply on meter squared divided by Coulomb in square. So, and Q1 and Q2 are the values of charges. So, what can say this formula for us? And Coulomb's law, this formula, Coulomb's law, tell us that the greater distance between charges, the less force of their interaction, and opposite or vice versa, yeah? So, but this formula is valid only in a vacuum, when there is no external influence of the environment in which the interaction takes place. If the interaction takes place not in vacuum, but in some medium or in some substances, then we understand that it also contains charges that can affect the interaction. But how? They reduce the strength of this impact. There is a special physical quantity that shows how many times the medium weakens the interaction of charges. This is the dielectric constant of medium. Dielectric constant of medium. And we take for this the Greek letter epsilon. Yeah, Greek letter epsilon. What is this? This is the ratio of the force of interaction of charges in a vacuum to the force of their interaction in the medium. Shows how many times the environment weakens the interaction. And so, according to this, the formula of Coulomb's law will be as follows. We must add in this formula the epsilon, the dielectric constant of the medium. And we understand that this value shows us how many times the environment weakens the interaction. So we must put it here. Less number of dielectric constant of medium, more number of force. And the opposite or vice versa. So we now know what an electric charge is, and we understood that the charges interact with each other. But how does it happen? How does this happen? But what is it? The concept of an electrostatic field was introduced by Michael Faraday. So there is an electrostatic field. And electrostatic field is a special type of matter. You can see the definition of this physical quantity, physical value, with the help of which the interaction between charged bodies is carried out. It has one peculiarity. It can't be detected by our senses. Don't forget about it. It can't be detected by sense organs. Any electric charges create an electrostatic field around itself. So there is the electrostatic field around the charges, which is characterized by such a physical quantity as the strength of the electrostatic field. But this is the strength characteristic of the field. But about it, we will talk sometimes later, yeah? And now we understood that there is the electrostatic field around charges. And now we see the definition of it, and we must understand the properties, the special properties of electrostatic field for the best understanding. What is it? Firstly, we consider in detail with you the properties of electrostatic field. The first property is that the electrostatic field is created by charged bodies. And we said that around the charges around the charges, or around there is the electrostatic field around the charges, or charged bodies can create around it the electrostatic field, but not can, must create. Yeah, it may be everything, every time, everywhere. There is the electrostatic field around the charge, around the bodies, charged, only charged bodies. So the second characteristic, impossible to see, or the electrostatic field can't be detected by sense organs, how we said earlier. It has no taste. We can't eat it. It has no smell. You and I don't see or hear it. And it can only be detected by its action. That is, we can only see the result of interaction. The result is attraction or repulsion. That's all. And so, how can we draw the electrostatic field? We must draw the electrostatic field in tasks and for the best understanding. And so, electrostatic field is schematically depicted using lines of force, or using force lines that start with the plus charge, start from plus charge. Let's see the arrows, the arrows from, with direction from plus charge, and come to minus, or finished in the minus charge. So the direction of arrows to minus charge. So on this picture we can see the interaction, of these charges. So firstly, this is the attraction, and so we can see force lines go out from plus. We can see the direction, and come to minus, and after this we can see only the result. The result is attraction of these different charges. Please don't forget it, and you should understand it. And the last characteristic of electrostatic field is that the electrostatic field is characterized by a physical quantity. This is field strength. This is a strength of electric field, of electrostatic field, So, the strength, what is about the strength of electrostatic field? We must say some words about it. Let's see the definition of this position, of this value. So, this is the vector of the vector physical quantity. Firstly, we must remember that it's not simple physical quantity. This is a vector physical quantity, which is the force characteristic of the field and determines the force of the electrostatic field to act on the introduced into the electrostatic field charge. So we can see the formula. How can we calculate this? Yeah, we said this is a force characteristic, and the electrostatic field, let's see on the picture. We have a charge, and charge has the electrostatic field around it. And so if we take other positive charge, for example, and put it in this electrostatic field, what happened? This big charge connect on this small charge, small positive charge, with the electrostatic field, and with electrostatic field strength, this is the E, vector E. And how much force we can act on this charge. And what is about F? This is the force of acting on a charge, and Q is the charge, this small charge. So what is about physical system international units of this value? You can see force in Newton divided by Q, charge is Coulomb, so divided. And for example, let's put the meter for every unit. What happened with the after? If we remember that Newton multiplied on meter is joule. So what happened? Joule divided by Coulomb is volt. So system international units of the electric field strength is volt divided by meter. Volt divided by meter. Please don't forget these system international units. Now let's talk briefly not just about the charge, but already about system of charges, yeah? But so far only about the simplest system. For example, when two electric charges of the same magnitude and opposite sign are bound together, they can form an electric dipole. Yeah, this is the system of charges, electric dipole. And the electric dipole, this is a complex system with positive and negative charge. Complex system, not divide, yeah? And it can act on different charges, on different dipoles maybe. And it has a special value which characterized it. This is a dipole moment. And dipole moment of this arrangement is the source of a characteristic electrostatic field, the dipole field. The dipole moment of two charges is defined to be. How can we calculate it, yeah? How can we calculate it? P is the Q multiplied on D, where is D the vector, special vector D, that points from the negative charge to the positive charge, So we can remember the dipole moment, which can, and this physical quantity can characterize the electric dipole. And please don't forget this information about the electric dipole, because when we will talk about our conductive system of heart, we will return to this position. To electric dipole. So please remember it. And let's think. For example, if we have the electric dipole, and we take the electric dipole and place it in an external electrostatic field, what happened will be? Let us consider such a case when a dipole is placed in a uniform electrostatic field, a field with the field strength E. What will happen? When an electric dipole with the dipole moment P is placed in a uniform electric field E, this outside electric field E, you can see pink arrows. So it starts to rotate, this dipole. What happened? It starts to rotate. And the dipole rotates so that the forces of charges are parallel to the electric field. Let's see, yeah? We have a outside electric field. And we know that positive charge and negative charge connect on this outside electric field. And this outside electric field connects on these charges and have a directions. Charges the same number, charges have the same number, but the different mark, yeah, positive or negative. And so the forces will be the same number, but opposite direction and minus and plus. So if we can summarize it, what happened? What happened? That sum of these forces acting in system is equal to 0. But the points of application are different. Therefore, a torque arises. So the dipole tries to turn so that the vector of the dipole moment is parallel to vector of tangent. So P vector, the dipole moment P, must be parallel of outside electric field. And so this dipole can rotate. How? That the vector P must parallel to outside electric field. So let's continue. We have previously discussed the power characteristic of, or force characteristic of the electrostatic field. It was the strength of electrostatic field, yeah? Now, let's discuss electrical performance, yeah? Because the electrostatic field must have the electric electrical characteristic, yeah? And so this is the potential. Electric potential, let's see the definition. What is about electric potential? Firstly, this is a physical quantity, especially, yeah? That is an electrical characteristic of an electrostatic field and determines the potential energy that a charged body introduced into this field will possess. So let's see the formula on the slide. We put the letter of electric potential is phi. This is the Greek letter phi. How can we calculate it? We must put the electric field work W divided by charge Q. That's all. We can see system international unit of this value. What will be? So the work is joule, the charge is coulomb. If we divide joule by coulomb, we have a volt. So system international unit of electric potential is voltage. So on volt. And if we say that since the field, electrostatic field, can act on a charge, yeah, then it does work. So we can calculate this field work using the following formula. How can we calculate the electric field work? We should multiply Q on difference potential. On difference potential of, for example, of our conductor. So after that we know the field work. Pay attention. We talked with you about the charge, about the interaction of charges, about the electrostatic field, about its properties, yeah? And now we will go directly to the electric current. What is electric current? Let's see the definition. Electric current is the directed movement of charged particles, yeah? In Russia we have, I say my students every time that we have 4 words. In English we have 5 words, the directed movement of charged particles or charged bodies or charges maybe. So the charges themselves will not move. It takes strength to make them move. And she is. This is an electromotive force. What is about electromotive force? This is potential difference at the terminals on plus and minus of the battery when the electrical circuit is open. Knowing that there is an electric current, we understand that there is also a concept of the strength of this current. Yeah? And before this, we must remember that charges cannot go without energy. So it must be energy which can, or the force which can give the energy to them to acting, to go into movement, yeah? And so it is the electromotive force. And let's say about current. What is about current? The letter I. This is a quantity that indicates an electric charge that has passed through the cross section of the conductor per unit of time. You can see the formula on the slide. And the strength of the current characterizes the rate at which the charge follows through the conductor. You can see it. So, what is about system international unit of current? Especially, this is the ampere. What is about ampere? Coulomb divided by second. Coulomb divided by second. Don't forget about it, please. So, in order for electric current to appear, special conditions are necessary for us. For appearing the current, for creation, how can we create the current? We must have the special conditions for the occurrence of the electric current. What conditions? Firstly, the presence of an electrostatic field which ensures the movement of charges as a result of the action of the current source. Don't forget, this is the first. And the second, the presence of free charge carries. It may be electrons or ion in the gas. So we can see on the picture. In metals, the charge carries free electrons. In liquids and gases, charge carriers are ions. Don't forget, please, about it. Metals, electrons, liquids and gases, ions. So, note that in metals, don't forget about it. Don't forget, please, about it. Metals, electrons, gases and liquids, ions. So, in what other way can we calculate the strength of the electric current that has passed through the conductor? With the help of Ohm's law. I think all of you know about Ohm's law and hear this name, yeah? Ohm's law is an experimentally obtained empirical law that established the relationship between the current in a conductor and the voltage at the ends of the conductor, and its resistance was discovered in 1826 by the German experimental physicist Georg Ohm. A straight formulation of Ohm's law can be written as follows. The current in a conductor is directly proportional to the voltage at its ends, potential, and is inversely proportional to the resistance of this conductor. A conductor is included in the electrical circuit on which, using an ampermeter and voltmeter, we measure that the current I and the voltage V, respectively. When there are several current sources in the circuit, it's possible to observe the dependence of the current strength of the voltage. Voltage is the physical quantity that characterizes the works on of an electric field to move a charge. And so I put in this voltage, you know, that is letter V, but in Russia we use the letter U. And this is a physical quantity, which characterizes the work of an electric field to move charge. So how can we calculate the voltage? We must put the work of a field divided by a charge, like as a difference potential, difference potential, electric potential, how we said in here, So system international gain of voltage is volt. Don't forget, please, about it. And also note that the denominator of the formula is electrical resistance. What is about electrical resistance? R. Electrical resistance R from the Ohm's law, when we voltage divide by electrical resistance. What is this? Electrical resistance is a physical quantity that characterizes the ability of a conductor to pass an electric current. A conductor that has electrical resistance is called a resistor. I think you know this. Let us draw your attention to the fact that the electrical resistance does not depend on either the current strength or the voltage in the circuit from this Ohm's law. Then what does it depend on? It's very simple. Consider the formula for electrical resistance. We can see that the resistance depends on the type, substances, or resistivity of the conductor is made, and also on the conductor length and cross-sectional area of the conductor S. So don't forget that System International of the resistance is Ohm. I think you know this. So don't forget that the electrical resistance does not depend on either the current strength or the voltage in the circuit. Please, you must know this position. So now let us discuss with you the electrical current in different substances of various kinds. Firstly, let's start with the metals. We will talk about metals, or liquids and gases. I think the simplest for you is the metals. So, metals are the good conductors of electric current because they have free electrons that are charge carriers. I think you understand this position from my lecture. So, and free electrons move along a conductor under the action of an electric field, and after that they can conduct the electricity, and we can use the electricity, and we can use our telephones, our computers, and for example in the kitchen, the special devices, and other, and especially it may be the kettle, and maybe the washing machine, and other devices. So then next kind of substance is liquids. Substances with ionic conductivity are called electrolytes. we said that in liquids and in gases there are the ions, and ions can carry down the charges. So, for example, what is about electrolytes? It may be solutions of salts, acids, and alkalis. I think you know it from chemistry. So, ionic conductivity is due to electrolytic dissociation. The breakdown of molecules into ions under the action of a solvent molecule. As a result, ions are formed that are the same magnitude and opposite in sign. The electrostatic field causes them to move in orderly manner, resulting in an electric current. From the course of chemistry course, you are well aware of the one phenomenon that is associated with electricity and liquids solutions. This is electrolysis. And electrolysis is the release of the constituent parts of the solute on the electrodes immersed in the electrolyte. In this case, the reactions that occur during electrolysis on the electrodes are secondary, and the dissociation reactions in the electrolyte are primary. So, let's see on the picture. We have a anode and cathode, with the electricity, with the charge, so with the power. And let's put it in the solution. For example, acid, for example, chloric acid. So, what happened if we have an energy? The protons will be the primary reaction in this liquid. It is a dissociation reaction in the electrolyte. So, acid dissociate by protons and ions of chlorine. So, what happened after? Will be the secondary reactions that occur during electrolysis on the electrodes. So, positive go to negative cathode, and negative ions of chlorine come to positive anode. And that is electrolysis. I think you know this position. So, research on electrolysis in the 19th century was carried out by Michael Faraday. In an effort to establish quantitative relationships between various manifestations of electricity, he began experimental research on electrolysis and discovered its laws. These laws were a serious argument in favor of the discreteness of matter and electricity. In addition, the discovery of these laws was, of course, of great practical importance for electrochemistry and technology. And the first Faraday's law, what is about? The mass of a substance released at the electrode is directly proportional to the electric charge passed through the electrolyte. And the second Faraday's law, the electrochemical equivalents of various substances are proportional to their molar masses and inversely proportional to the numbers expressing their chemical valence. So, about electrolysis, about Faraday's laws, I think you talked or will talk in chemistry lessons in the department of chemistry, But I should not say with you about it some more words, only like as a additional information for best understanding of the electric current in liquids. So, but on these laws, the based a very special part. And based on these laws, electrolysis is used to administer certain medical substances through the skin. This method is called electrophoresis. I think you know about electrophoresis again from chemistry, when we can divide the matter and it goes through the special substance, and after that we can see the lines. But I say about physiotherapeutic method, electrophoresis. What is about it? Let's see the picture. Photo from the how can we treat, for example, the knee of our patient using the electrophoresis and electric current. How it can be. A medical substance is applied to the tissue placed on the body, the area of administration of the substances, or in the area where patient have a pain. An electrode is superimposed on top. The second is the next or top on the opposite side of the body. For example, in the knee is right or left part. For example, in the intestine, up and down on the neck maybe, and other. A weak direct current is applied to the electrodes. Under the action of an electric current, the solution molecules are dissociated and the resulting ions can penetrate the skin into the body, and we can take the drug, for example, the special drug, put it on the electrodes, and using electric current, this drug can dissociate on ions, and the ions is the active form of drug, and after that ions can go through our skin better than the drug. And what happened after? You can see, for example, the scheme in here, the scheme of electrophoresis, when we have two different electrodes, when we have a drug and it can divide or dissociate by an electricity. So, electrophoresis is widely used in physiotherapy, as it has several benefits. Let's consider them in more details. What is the benefits, or what is the positive ideas of this? Why can we use it? Why especially this method is used by sportsmen in sport medicine. And what is the benefits? The introduction of small doses locally, for example, on a joint or muscle, therefore the negative effect of drug is reduced. We can use the small doses of drug. It's very necessary for our intestine, for example, if we use the tablet form of drugs, or we can reduce the negative effect of these drugs, especially on our kidneys. So, the next is the accumulation of the substance and the creation of a depot. This provides a prolonged or long-term effect of the drug. So, it's better for us, we can use only the small doses of the drug. Put it only in the seat of pain without bad or negative effect of this drug. And After that, these ions can accumulate in this area and can act on slowly and continuously. Yeah. So, what is next? Introduction of the substance in the most of active form of ions. And here we can say the possibility of creating a high local concentration. Yeah. We put active form of substance and we can create the high local concentration of the active substance without saturating all the organs of the digestive tract and excretory system with it. Kidneys, intestine, stomach, yeah, and other our organs. And a local introduction into the lesion focus. We can act only the focus, yeah, focus of pain. I said it earlier. But electrophoresis also has limitation in its applications. These are the following contraindications, maybe really. We can't use every time, everywhere the electrophoresis. We can't use this in patient with oncology. A patient with acute inflammation, especially acute inflammation, both general and the injection side, fever, wounds, yeah, because the inflammation of our body, this is a special reaction of our body and special reaction of our immunity system. And this system can collect the strength and acts only on the seat of pain. And so if we, for example, if our patient have an acute inflammation, for example, it has a cough or it has a fever, and for example, it have a trauma, for example, in the knee, and if we use in this and if we use electrophoresis on this knee, what happened? We can divide our immunity system, yeah, our force of immunity system, and it's not good for us. And after that, we can have the bad position for our inflammation, acute inflammation or fever, or cough. It's not good for us, it's not good for our patient. And so when you will be the doctors, you will not use the physiotherapeutic methods, for example, electrophoresis and other physiotherapeutic methods, when our patient have an acute inflammation, especially oncology, because it's a contraindication for this. So don't forget about it. And at the end of this lecture will be electric current in gases. Under normal conditions, gases practically don't conduct electric current, since the gas molecules are neutral. When heated or exposed to radiation, gases are ionized. As a result, 3 types of charges appears: positive ions, negative ions, and electrons. And the set of processes of electric current flowing through a gas is called as a gas discharge. You can see it on the picture. Between 2 electrodes, we can create the gas discharge after gas ionization. Yeah, after gas ionization. Don't forget about it, please. Now we should end our lecture. Yeah, I must end my lecture about electricity. I recommend to you see this lecture very accurate, yeah, and remember all positions, all definitions, and all formulas for best understanding, because this information will not repeat in practice lessons. So please be careful with it, and because this information will be at the end, the chart of our on our department of our lessons. Yeah, so I must say thank you for the attention, and I will wait you on my next lecture on next Monday. Goodbye, and thank you for your attention again.